Good morning all. Shall we test a PCB? Shall we test this PCB, the input amplifier? It's all analog electronics. So remove the two knobs. These nuts are 10 millimeters and these nuts I think are just finger tight. Oh well, tight finger tight. So here's the printed circuit board I'm going to test. It's more of a module really, isn't it? Pots on the top, full-size 1/4-inch jack sockets on the bottom, and RCA sockets on the back here. Here's power. It needs plus 12 volts and minus 12 volts. And today I'm going to use a proper bench power supply. Here it is. It's a power supply and it's on my bench. That makes it a bench power supply. Let's rig it up. Now this thing has its dual op amps removed, so I've got to put those in. We've got a 1458, which is a sort of dual 741 type op amp. In it goes. And it's got a 4558, which was an early low noise dual op amp, and it's using that one for the microphone gain stage, because the output from a microphone is just a few millivolts. We need to get that up to about a volt so that I can feed it into an audio amplifier. I'm going to need an audio amplifier. So 3.5 millimeter stereo plug into its aux input, switch it on, and to save those wearing headphones, I'll start with this down on the floor, and then if it turns out not to be loud enough, I'll bring it closer. Now these phono outputs are all paralleled up, so they all provide the same signal. So what I'm going to do is plug left channel into one and right channel into another one. So I'm just sending the same output signal to both sides of my amplifier. It's kind of mono twice. This is my 12012. Let's plug that in. Switch on and see if there's a loud clunk. Oh, there's certainly some hiss. I'll bring the speaker up a bit closer. Well, it's not so much hiss, it's more of a sort of squally noise. The other thing I need is a microphone to plug into the microphone input socket, and then I can see whether this works. Now, here's a bit of a spoiler. It doesn't work, because I made a bit of an error. So let's plug in the microphone. That goes into the left socket because it's going to be that way around on the front panel. Turn up the volume and nothing appears to be happening. Turn the tone control. Nothing appears to be happening. So I will speak into this microphone. Speaking into the microphone, turning up the volume control. And absolutely nothing happens. Oh, the squeal has changed slightly in tone. Let's turn up the tone control. Well, I heard a click and the squally noise has changed slightly, but listen to this. If I shout really loud into the microphone, I can get a very distorted sound out of the speaker. Clearly something's not right. So I've repositioned stuff on my desk so it's a little easier to see what's going on. Now, when this happened, I changed the two ICs, thinking perhaps they might be damaged. No, they were fine. So then I thought, well, I'll take a look at the schematic, the original circuit diagrams for this thing, and see if I can see anything there. So that's when I thought, have I been incredibly stupid and ignored my own little yellow post-it notes, this one which says op amps input wrong. The plus input of this op amp goes to the pot, the minus input goes to the feedback resistor and capacitor. And it would have to do that because if you have a feedback resistor going from output to positive, well, you're going to get positive feedback, which means that this is going to work as a comparator and flip from rail to rail. This one, similarly, is wrong. The op amp inputs have been marked the wrong way around. And guess what I did? I copied these errors onto my PCB and had it manufactured.
Stupid!
Yeah, how annoying. My input amplifier board has those errors actually on it. Let's power this off just for the moment. Now I've taken to doing most of my track work, the audio track work, on the top side and doing my power tracks on the underside. Generally speaking, I mean, it can't always be like that. That means that the audio tracks that need to be swapped over are on the top, and that makes it really quite difficult to cut tracks and reroute them, because I've got sockets here which you can't really easily get underneath to put the wires into the new positions. So what I thought was, okay, what I'll do is I'll actually flip the pins on the chip. So I came up with this. It's a pair of dual op amps with their legs kind of bent up and wires soldered on, which have been crossed over to replace the original pins. So this should do the trick. Let's plug these in. Let's take these ones out, lift them out. Oh, that's a bit stuck. Why is that stuck? And take this one out. Okay, let's plug in my new chips with crossed over legs. That's the 1458. Where's pin 1? There it is. So that goes in there. They fit really quite well. Let's put that one in. Okay, is my power amp on? I think it is. Let's turn on the power. Right, now let's try the microphone. Here's the microphone, and I'll gradually start turning up the microphone volume. Why am I not hearing anything? Unbelievable, I'm not concentrating. I actually put that chip in the wrong way around, and it got very warm, but still seems to be working, because if I turn up the volume, yeah, we're getting a very good sound quality now from the microphone, my microphone here, through the microphone input amplifier. So with these legs crossed over, it's working perfectly. The tone control works. If I turn it that way, it goes much more towards a treble boost and a bass cut. And if I turn it this way, it goes into a bass boost, which this speaker can't really handle, and a treble cut. Let's turn it back to the center point. So my input amplifier works. Awesome. Now there is one component missing from this board. It's a 68 picofarad capacitor, which doesn't sound like it's going to do a lot, but it's in the feedback of this op amp. We can take another look at the circuit here. So on the schematic of this microphone amplifier, here's the 68 picofarad capacitor. It's across this 100k resistor, which provides the feedback for this op amp. Remember, this is negative here, or inverting, and this one, which goes to the output of the pot, is non-inverting. Now what this means is that at high frequencies, the impedance of this capacitor will be relatively low. So it would behave as a low value resistor across this 100k resistor. That means that at high frequencies, it will reduce the gain of this op amp. So it's a high frequency roll off. It stops high frequencies passing through this section of the circuit. So let's see if we can see it working in action, or hear it, I should say. Now with the microphone disconnected, I'm getting some funny noises coming out of this thing when I turn the volume up, getting hiss and hum, but at a certain point getting this really squally sound, which sounds like there are a lot of nasty high frequencies in there. Let's see if the tone... Oh yeah, the tone control affects that as well. Getting quite a lot of 50 Hz mains hum as well. There's quite a lot of mains in this room. Let's put that 68 picofarad capacitor in and see how that affects it. So this is the set of low value capacitors that I got in the other day, with a few not low values in there mixed in as well. Rather odd. There's the 68. That looks like it's going to be perfect because it's got a 5mm pitch. So I'm going to drop that in the board, and I'm going to do it with the power on to see if we can hear any difference. There's that fuzz and squall. Let's put this in. It's probably not making a connection. Yeah, and you can see that that's taken out that squally sound. I'm still getting some hiss and some hum, but that squally sound, if I hold that capacitor in so that it makes a connection, has been removed, even with the tone control in its... Oh, I think that was my phone, my mobile phone. And if I let go of that capacitor, the squally sound comes back. So yeah, it's doing its job. It's taking out frequencies which are probably mostly ultrasonic that we can't actually hear, but which are causing major problems in the circuit. So yeah, that capacitor's doing its job. This isn't very pretty, is it, with these sticking up dead bug style legs on both of my op amps. It just doesn't look very professional, does it? So I thought, I wonder if I can actually improve the look of that. So I came up with this, and I don't know whether you can see this, you probably will with a magnifying glass. I've actually crossed over two of the legs of this chip so that it works on my printed circuit board. Let's give it a try. They're very close, but they're actually just not touching. So let's put that one in. I haven't done the one where the two, you see this one of the legs is a thin one because it's one of the end legs, so it was slightly easier to do. But the other one, I'm going to have to do the two middle legs. That might be a bit more tricky, but I'm going to put this one in. And it's this one, the LM1458. So I'll take out my obviously giveaway one. Let's get this the right way around this time. Put this one in with its crossed over legs. Apply power, connect up the speaker, and see what we get. Hello, 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 hello. Well, that works rather well, doesn't it? Yeah, that's working fine. So now I need an RC4558. Try and bend the two middle legs so that they're cross-legged, and then, well, no one would ever know. Yeah, I have started working on a V2 of this PCB. Yeah, this one's going to be more of a challenge. I'm thinking I might bend one of the legs really flat to start with, so that it's flatter against the body. Bring the other leg across it. It's going to need quite a bend on it though, isn't it? And then bend the other leg underneath. Yeah, probably have to do this off camera. So what do we think about that? It's not pretty, but it should be relatively invisible from a distance. Let's pop it in and give it a try. The other thing I just want to check is on the schematic, if those two do short, is it actually going to cause a problem with power supply shorting? So let's have a quick look at that. Well, let's see if we short plus and minus out here. If this pot's at ground, we could take these down to ground. I can't see that being a major problem. Also here we've got a 100k resistor, capacitor, 11k resistor. That one should be all right. What if we short these two over? Again, this one's on ground, but this one has, well, resistor there, resistor there, resistor there, resistor there. No, this one's protected. It's not going to cause a problem. Okie dokie. So there it is, and from a distance you'd be hard pushed to see that there's a problem. If you look a bit closer, yes, you can see that chips have their legs crossed over. Okay, let's switch on the microphone. Oh yes, oh, we got some sound there. Oh, I think I had my finger on one of these connectors down here, which was giving rise to that squally sound, but that sounds pretty good to me. Let's try taking it more to the treble side, more to the bass side, raising the volume. We will get feedback. Lowering the volume. Good. My input amplifier board, my microphone preamp, This is the microphone socket, and the one next to it is a line socket, line level. It works. So let's have another look at the crossed over legs. Oh yes, that one is a beauty. You wouldn't spot that from a distance, would you? And this one is on this side. Look at that. That's awesome. And I've just spotted that that capacitor hasn't yet been soldered in. So I will do that. But apart from all of that, this input amplifier module, I think, is a goer. Cheerio.